Welcome to the course of problem solving and programming. So this class I'm going to discuss about the forward loop and inverse loop, how to draw flowchart for the forward loop as well as inverse loop. I'm taking the example of checking whether the given number is prime or not. So I'm going to draw both the forward loop as well as inverse loop for that. Draw flowcharts for the forward loop and inverse loop. Algorithm and flowchart. To check whether the given number is prime or not. So since we know the algorithm process how to write, I'm directly writing the pseudocode for this. Yeah, so fine. Now what is prime number? Suppose I can say that if I take a number 19, I can say that 19 is a prime number. How can I say that? It can be divisible by 1 and it won't, I'm going to check the values of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So a number is called as prime number if it is divisible by 1 and its own, that means 19, then it is a prime number. That means if a number n is divisible by only 1 and n itself, then it's called as prime number. Else it's not a prime number, because the 19 cannot be divisible by 2. 19 is not divisible by 2. Then 19 is not divisible by 3. 19 is not divisible by 4. 5, no. 6, 7. 7 is not possible. Okay, fine. 8 is not possible. 9 is not possible. 10 is not possible. 11 is not possible. 12 is not possible. 13 is not possible. 14 is not possible. 15 is not possible. 16 is not possible. 17 is not possible. 18 is not possible. So it is not divisible by any other number except 1 and 19. So I can call it as a prime number. So now how to write an algorithm for this? So I have to ignore 1 and I have to ignore n. So I have to perform the operation from 2 onwards. How a number can be divisible by particular number or not? Suppose 19, how it is divisible by 3? How I am saying that it is divisible by 3 or not? So 19 divided by 3, then it is 6 times 18, remainder is 1. So if remainder is not equal to 0, then it is not divisible. If remainder is equal to 0, then it is divisible. So equal to 0, not equal to, remainder value equal to 0, not equal to 0 will decide whether the number is divisible by a particular value or not. So 19 I can check 9 also. If I check with 9, then 2 9s are 2, 18 and remainder is 1. 19 I can check 11. 1, 11 is 11 and remaining is 8. So it is not divisible by any of the number. Likewise you can check using the division operation. You can perform this kind of division operation with every number and you can check whether the 19 is divisible by particular number or not. So fine. Now how to write a program? So I'm starting I at 2. I'm checking whether 19 is divisible by 2 or not. I'm starting I at next time making I as 3, I4, I5, that means I value is getting incremented by 1 and I am checking whether it is divisible by 19 or not. That means given n or not. So fine. So based on this one, how can I write the program? One is forward loop. I'm explaining the forward loop, and second one is inverse loop. Yeah. So forward and reverse loop, otherwise inverse loop or reverse loop. So fine. Now I'm writing both the algorithms. So algorithm check prime is my number. Yeah. Algorithm for checking prime underscore forward loop. So forward I'm making. Then in this algorithm, first time what I'm doing, input number. Yeah, fine. So while doing this process, if a number is divisible by any of this, suppose if I take 25, then it is not divisible by 2, it is not divisible by 3, it is not divisible by 4, it is divisible by 5. Whenever it is divisible by 5, I'll stop the process. I need not check the remaining numbers, 6, 7, 8, 9, all these numbers I need not check. For example, 18 if I take, not 18, take any other, any even number is divisible by 2, that is fine. I can take number 39. 39 is divisible by 2 and 39 is divisible by, not divisible by 2, 39 is divisible by 3. So once it is divisible by 3, I need not check about 4, 5. So since 13 is also divisible by 39, I need not check up to that. One number is sufficient to stop the process. So whenever n is divisible by n is divisible with some particular number, we can stop the process at that place. So I'm taking one flag. I'm making it as 0. Whenever it is divisible by a particular number, then I will make the flag value as 1 and I'll stop the process. Then I'm starting the process of I from 2 onwards. So how can I write this? If I is less than num, what could be the I value, initial value? I equal to 2. Initial value of I equal to 2. If I less than num, then I'm going to check whether it is divisible by number or not. So if number divisible by I, that means mod I equal to 0, then so what I'm going to do, then immediately I'll make flag value as 1. I'll stop the process, break. Break is a keyword to stop the process of this loop. So I'm stopping the process. Then otherwise I can do go to step, particular step. So go to step. Okay, I'll write step. Otherwise go to down. That is fine. Go to down. So fine. If number is divisible by I, then go to down. Otherwise, what I will do, I will increment the I value by 1. And I'll check again whether this number is divisible by with I, the incremented number is divisible by with I or not. Go to up. What I am doing, up. So whenever if this condition is false, then I'll come here, end if. I can do end if here itself, sorry. This end if will be here itself. And this one will be here. Yeah. So once after completion of this step, what I am going to do, I am going to check whether the flag value is 1 or not. So now again I am checking if flag equal to 1. Then it's not a prime number. Then print not a prime. Because if flag equal to 1 in the sense, it is divisible by particular number. So else print prime. So I can stop the process now because it's a end if n. So now I'm going to iterate the value. So take an example, number equal to some 7, and second case, number equal to some 9, not 9, I will take what is the value, I can take it as 10. Fine. I can take it as a 10. So fine. Two cases are there. One number equal to 7 and number equal to 10. This is case 1 and this is case 2. I'm going to evaluate both the things. Case 1, case 2. So how I can check these kind of things in the sense, number equal to 7 in the sense, first I value, I'm going to perform the I value and num mod I value, and I need the flag value. So flag value will be common for both the programs. Yeah, flag value. So initial I value is 2, flag value is 0, num mod I, so 7 mod 2 false, 7 mod 2 is false, that is 7 mod 2 is 1, so it is not equal to 0, num mod I is not equal to 0 because num mod I is 1, 1 is not equal to 0, then I am going to increment the value of I, that is 3. So fine, 7 mod 3, 7 mod 3 in the sense it is again 1. So fine, 1 is not equal to 0, then I am going to increment the value of I. 7 mod 4, 7 mod 4 is equivalent to 3. So 3 is not equal to 0. Then 7 mod 5, I value incremented, 7 mod 5, that is 2. 2 is not equal to 0. Then I value is incremented, 7 mod 6, that is 1. 1 is not equal to 0. Then I value is 7. So this condition is 7 less than 7 is false. Then I'll come out of the if. Then flag value, I'll check flag value is 0 only, then it is a prime number. Yeah. Then next case, again I value will be starting at 2 and num mod I. So now I value is 2, 10 mod 2, it is 0. So first I will check that 2 less than 10, condition true, then 10 mod 2, 10 mod 2 is equivalent to 0, 0 equal to 0, then flag value will become 1. So now go to down means where I have to go, here I have to go. Yeah, fine. So if flag equal to 1, if flag equal to 1 in the sense, yeah, flag value is 1, so it is a not a prime. Yeah, fine. This is forward loop. Where is the loop? Sir, you are saying that this loop is there. So this statement go to up, since this go to up is there, this is a iterative loop. So this I can write it as while or until. Okay. So I can write it as a while in the pseudocode. While in the sense till the condition is true. So it is nothing but if and go to up. So since I am repeating this process till the condition is true, I can write like, so input number, okay, flag equal to 0 and I equal to 2 while I less than num, because I am repeating this process, while I less than num. So then I am going to check if number mod I equal to 0, then flag equal to 1, break the while loop. Break is a keyword to break the while loop. Okay, then end if I equal to I plus 1, end while. I can write it as do. Do the following steps until the condition is true. So that means I value incremented, I value decremented. Whenever I less than I equal to num, then the process will be terminated. So remaining everything is fine. Whatever we are drawing, that means this step is fine. if flag equal to 1, everything is fine. That is same step. So this down variable will not be there, because whenever it is break, automatically it will come out of the while loop. So break will send you out of the while loop. Send the pointer to out of while. Now, so this is so I'm drawing two flowcharts for this. Yeah, fine. I'm drawing two flowcharts for forward. So forward and inverse. So totally three flowcharts I'll draw. I'll show. Yeah, start the process. First using if. Then I'm going to read the number. So reading of number. This is reading of number. Then I'm going to yeah, fine. I'm going to create initialize both flag and I value. This is initialization of flag and I. Then next I'm going to check the condition I less than num. Yeah. Then I'm going to check yeah. So what I have to do next step? So then I'm going to check if I less than num, then I'm going to check if yeah. If num less than I. So fine. I'm going to keep the flowchart side by. Then so if both the things are fine, then I'm going to break everything. So by making flag equal to 1. So then I'm going to check if flag equal to 1 or not. Yeah. So then if flag equal to 1, then break. So sorry, I'm going to print it as a prime. Else I'm going to print it as not a prime. Yeah. Then I have to increment the value of I. So increment the value of I. So I can make this incrementation here directly. Yeah, fine. So this is a simple flowchart. I'm going to draw. So this will be the stop. So fine. So now I'm going to give the connections. This is start, and this will be input n. Then I'm going to make it as I equal to 2 and flag equal to 0. So simple operation. Then I'm going to check is I less than num, sorry, I less than n. If it is I less than n, yeah. If it is I less than n, what I can do is I can check the next thing is yeah, fine. The next thing is I'm going to check it as so is n num mod I equal to 0, otherwise n mod I equal to 0. Yeah, fine. If it is equal to 0, then what I have to do, flag equal to 1. So I'm going out of the loop. So otherwise I'm incrementing the value of I equal to I plus 1, and I'm going to check that f2 is flag equal to 1, then it's not a prime number. f2 print not a prime, else print as a prime number. Then I'm going to check, I'm going to connect with yeah, connector should be there. Yeah, I'm going to keep a connector over here, so everything will be connected properly and fine. I'm going to draw the arrows. So this is and this one will be next arrow, and this one will be next arrow, and this one and this one. Yeah, fine. And this one will be next arrow. So, and from here I'm going to check whether I less than n value or not. Then from here I'm going to directly so here also if flag equal to 1, then from here also I'm going to this step. So this one will not be there. Yeah. So fine, and I'm going to print it is a one case will be prime and another case will be not a prime. Yeah, fine. So now I'm going to connect these two things to the arrow, sorry, connector. So fine, from connector I'm connecting it to the stop. So this is the flow chart which can check whether the given number is fine or not using if. So start input number as an I equal to 1, flag equal to 0, is I less than n. Okay, then I'm going to check n mod I equal to 0. If it is n mod I equal to 0, flag equal to 1, break. So I'm going to hit here. So this one will be false and this one will be true. And this one will be true. This one is false. So this one prime is true. And this one is false. So this is the flow chart of checking whether the given number is prime or not. So entire flow will be there, very properly is done, and I'm saving this so that you will understand. Export. Yeah, fine. Okay, so I can keep the diagram here itself. So this is the complete flow diagram of this is the complete flow diagram of this is flow chart to check whether the given number is prime or not using if. So how can I do with the same using while? So there is a process. I'm going to draw the new flow chart, new one. So using while, so I'm save as, so forward flow chart while. So using while loop. So what I'm going to do using while, so start, yeah, fine, start. So then I'm going to read the number, then I'm going to make I equal to 0 and flag equal to 0, sorry, flag I equal to 2 and flag equal to 0. This can be done. Then I'm going to keep a loop. So this is the begin of loop, sorry, this is the begin of loop. Yeah, then in loop I'm going to check whether num equal to so fine, yeah, then I'm going to yeah, fine, I'm going to keep all these things little up. Then after that I'm going to check if num mod I n mod I equal to 0. If it is there, then flag equal to 1, and I'm going to stop the process. So this is flag equal to 1. So else I equal to I plus 1. Else I equal to I plus 1. Yeah. I equal to I plus 1. I'm going to do that 1 second. I equal to I plus 1. Yeah, fine. This is I equal to I plus 1. So once if it is I equal to I plus 1, then I'm going to iterate the loop. So this is end loop. So little red juice yeah, fine, this is end loop. So then after that I'm going to check whether the given so fine, after that I'm going to check using rhombus whether the given number is prime or not. Then print prime else not a prime. So now I'm going to end the process. I'm going to end the process using connector. So this is the connector, and the stop symbol. Stop symbol is terminator. Fine. So I'm going to start the process. This is start, and read number as n. Fine. I equal to 0 and flag equal to 1. So I equal to 2 and flag equal to 0. Then while condition I less than n. Yeah. Then is n mod I equal to 0. then flag equal to 1, yeah. So then next step will be F2, so fine. Next step will be I equal to I plus 1. This is iteration of loop, fine. Repeat loop. Then our final thing is flag equal to 1. Then I'm going to print it as a not a prime. Else it is a prime. So this one I can keep it here. So fine. And stop the process. So start, and this step and this step while by I less than n, and go to this step is n mod I equal to 0. If n mod I equal to 0, then go to this step flag equal to 1 and go to the flowchart directly. No need to iterate and loop, just directly come out of the loop. Otherwise I equal to I plus 1, repeat the loop. So once loop is over, then you have to come here. Then if it is true, then it is not a prime, otherwise it's a prime. So I'm connecting it to connector, then stop. So this is a simple example. So this one will be true, and so fine, this one will be false, this one is false, this one is true. So this is the simple flowchart using while loop. So I'm going to save it as a PNG image, so that I can import that PNG image here. So using while loop, you can see. So this is the flowchart using while loop. So likewise, we had done one example using while and forward and so if it is reverse while, so that is inverse loop, what I will do, so I will do just I value, I will make it as n minus 1, then I will make it as I greater than num, otherwise I greater than 1, yeah fine, I greater than 1 I can make it. This one will be I equal to I minus 1, just a change. That means generally I am going 2, 3, 4, 5, 6 checking. Instead of that, I will do n minus 1, n minus 2, n minus 3, n minus 4. Just I will do a reverse. So this is inverse loop. Hope you can draw the flowchart for this. That is not a big deal. So hope this clears the confusion how to draw a flowchart for while and iterative loops. So using if as well as using while. So and using inverse loop also we had seen. So just what we will do in the inverse loop in the sense. So we are going to change a small thing here. So just this statement will be modified as I equal to n minus 1, and this statement will be modified as while I greater than 1, and everything will be fine, and this statement will be modified as I equal to I minus 1. Rest all are fine. Just this is I greater than 1, and so that means instead of going from 2 to n minus 1, I am coming from n minus 1 to 2. That's it. So fine. Hope this has given clear information about both forward as well as inverse loop and using if. So next I'll explain the function calling with the flowchart in the next video. Thank you so much for listening.